Okay, students, now I will talk about question number 7, page number 3. There is spring connected with a box. The box mass is 75 kilogram. The force acting on the spring in this direction is 375 newtons, but acting on the spring on this direction, I will take it with negative sign as Hooke's law told us before. And also we know that the compression distance delta x is equal to 4 inches. I will convert it to centimeters. I will use the convergent coefficients from here. This is the conversion between centimeters and inches. 1 is equal to 2.54 centimeters over 1 inch. This is 1. I can multiply 1 by this value, which is 4 inches. I will cancel the units. So the displacement compression on the spring is 10 centimeters, 0.16, but I need it in meters. Each meter is 100 centimeters. This value is 1. I convert it from centimeters to meter. I cancel centimeters from here. It will be 0.1016 meters. Okay, this is the compression value. I need to find K, the compression coefficient for the spring. From Hooke's law is F is equal to negative K multiplied by the compression distance, which is X. Sometimes we can put it in plus, but we need to know more about the directions. Okay, now K, if I divide it over X, the both sides, then K is equal to negative F over X. Negative X, if we have know that F is negative 375. Negative with negative will be positive, and this is X. So the K for the spring, which is the spring constant, is 3690.94 newtons per meter. This is the unit for K. This is the first part. Now, if we see from part B, the spring is released and the force of the spring is accelerates the mass. So with respect to mass, this force from the spring is external force. From Newton's second law, F external is equal to the mass multiplied by its acceleration. We know the mass, which is 75. We need to compute the acceleration. The force, it's the same from the spring. It goes to the mass. So the acceleration is equal to force divided by the mass. The force from the spring is negative in this direction, but the mass on the body in this direction, it will be positive. So we put the force in positive value, which is positive 375 divided by the mass, which is 75, and we have the acceleration in this direction, positive direction, 5 meters per squared second. And the time to release this body is 2 seconds. Okay, the time for this force. Now, it asks us about the final velocity, the final when the body leaves the mass. At the initial point, the velocity is 0. But when the body leaves the mass, it has final velocity. We need to compute it. We know the time, it is 2 seconds. We know the acceleration, it's 5. Simply we can use this equation. V2 is equal to V1 plus AT. V final is equal to V initial, which is 0. V initial 0. V final, we need to compute it. The acceleration known and the time is known. So the final velocity here for this body is 10 meters per second. Okay, now this body moves 3 seconds after it leaves the spring. The question didn't give us any information about if there is any a friction force or not. So we suppose that we don't have any friction force. So the body will move on this surface freely. Its velocity here, which is 10 meters per second, it will still constant to finish its 3 seconds. Okay, how much the distance from leaving the spring to finish the 3 seconds? We can use this equation. X is equal to x naught. We can suppose it's 0 when it is leaving the spring, plus v. It is the v final here, v final for this period, but it is v initial for this period. Now v final is known, which is 10, multiplied by the time, which is 3 seconds. The acceleration is 0 because we don't have any acceleration in positive direction or in negative direction. The velocity will be constant. So this term will be 0. This term will be 0. So we will get back to the normal law to find the average velocity. X is equal to v multiplied by t. V is 10, t is 3, 0, 0. The total distance through 3 seconds is 30 meters. Okay, now for the next part, which is part E. If this body, I think it is here, yes, in page number 4. If the body now find another surface with a rubber surface between the body and the surface, there is a friction now. This friction make the velocity for the body comes to half of its value. Its value is 10. It's constant here. For 30 meters, the velocity is equal to 10, constant. But on this surface, the friction surface, the body becomes half of its value after 2 seconds. That's mean V final or V3. I name this point is 3. I name it V3. V3 is half of 10, which is 5. So V3 is equal to 5. Okay, what is the acceleration in this value? In this case, is it positive or negative? The velocity was 10, then goes to 5 during 2 seconds. The slope will be in negative value. If you remember that, if we have the time, here is the velocity, here is 10, here is 5. During 2 seconds, this is the first second, this is the second second, the velocity reduced. So the slope, which is the acceleration, is equal to delta V over delta T. We can use this equation, which is the same like this, because this is V final, V3 minus V final, V2, for example, over delta T. In this case, delta V is 5 minus 10, which is negative 5. Over 2 seconds, the acceleration will be negative 2.5 meters per second squared. Okay. Now we need to compute the friction coefficient mu. We don't know the friction force on this surface. We don't know the friction coefficient mu, but we know the normal force. The normal force is equal to mg, the weight, but to the upper direction. The weight is equal to the mass multiplied by the acceleration g. It will be 735 newtons, but to the upper direction. Also, In this case, we know that the external force on this body is the friction force. From Newton's second law, the total external force is equal to m multiplied by the acceleration. So the external force, which is the friction force, we can use it in the Newton's second law, which is equal to m multiplied by a. The mass is 75 kilograms. The acceleration is negative 2.5. The friction force in this case, which is the external force for this body, is equal to 187.5 newtons. And this sign, I put it here to be sure that the direction of the friction force is opposite the direction of the movement. So the value or the magnitude of the friction force is 187.5 without the negative sign, because the negative sign told us about the direction. Okay, finally, I know the friction force, I know the normal force, I don't know mu. I will divide over n, so mu is equal to F divided by n, divided over n. F is 187.5, n is equal to 735.0 newtons. So the friction force coefficient is unitless, because Newton over Newton is to go. Then the value is 0.255, or we can approximate it to two digits, and unitless. Okay, thank you. See you in the next example.